So we're going to take a look at linear and quadratic systems. So what we'll do is, this is a problem solving question. So we'll kind of read through it and we'll try to pull out the important info and make sense of it. So
Okay.
Samreen and Elijah are each saving money for a car. The total amount of money Samreen will save is expressed in the equation y equals 60 plus 5x. Okay. Sometimes it's good to read all the way through. One thing I'm going to do is we're just going to take note that this is a linear equation. We can tell by the power of x here, it's just technically to 1. So we know that this one is expressed as linear. Let's go to the next sentence. The total amount of money Elijah will save is expressed by the equation y. Now this is supposed to be x to the power of 2 plus 46. So this is quadratic. So we've took note that the first one is linear and second is quadratic. So that gives us some hints about potential answers. After how many weeks in x will Samreen and Elijah have the same amount of money saved? Okay. What I'm going to do is we're going to rewrite the two of them here. So we know that Samreen's equation was linear, y is equal to 60 plus 5x. Or I think it's a little more common if we write it in the y equals mx plus b. You might see it this way. So we have y is equal to 60 would be our slope. So that's how much it's changing by, and our y-intercept is the number. That should be 60, not 6. Okay. And then Elijah equation for saving money is very interesting. It's quadratic. Okay. Plus 46. Okay. And that's pretty standard, that one, so I don't have to rewrite that in any way. You could say this is in standard form. It is also could be potentially in a vertex form. I can talk about the two different ways you can express this one, but what we'll do is we'll just focus on how to solve the interaction or intersection of the two, okay? So question asks for after how many weeks? So weeks are expressed in x, okay? Well, Samreen and Elijah have the same amount of money. We're just going to do a quick rough estimate here. And actually, relating this one to standard form might be really helpful for this. So before I do that rough estimate, I am going to relate it. We'll say y is equal to, if you remember, standard form is a x squared plus b at x plus c. And normally, relating things to standard form for graphing isn't usually that helpful. But in this case, it does tell us the y-intercept. We know what the c value is. So make a rough estimate. It's about here at 46. And the y-intercept for the linear equation is at 60. So let's say it's somewhere up there. So we know, and I guess I should have drawn this a little better. We'll do the first one in red. Samreen's equation is something like this, where Elijah's equation is going to start lower, but it's probably going to eventually start heading upwards, okay? Now, pardon me, because quadratics technically are symmetrical and they go the other way, when we go to solve this, we'll have 2 points of intersection, but going back to the left would be negative weeks. And there is no going negative weeks for earning money, since the origin here, where x is equal to 0, that's when they've just started their job. They're 0 weeks in, okay? So when we get our two answers, we just got to be aware of the positive answer is going to be the one that we're looking for, okay? In order to solve this, really both of these equations are already set equal to y, which is great, which means we can set them both equal to each other. What we only need to do is I could substitute this value in for the y of the quadratic, and when we set them equal to each other, we can start to solve. So I'll start off by setting it equal over here. We'll start with 60 plus 5x is equal to x squared plus 46. So if you notice, the 60 plus 5x we put on the left side of the equation, and the right side of the equation here is that quadratic, okay? Now, I don't quite have all the room, so I'm going to jump to another page here. Hopefully I can remember it. 60 plus 5x. So we start with 60 plus 5x is equal to x squared plus 46. Okay, x squared plus 46. So what we want to do here is, it'll probably make the most sense to get everything to one side of the equation. Okay, you normally want to collect like terms, but if we take a quick look, we have two constant terms, but our x squared is the only term like it, so there's nothing to combine it with, and the x to the power of 1 is similar also. So what we'll do is we'll just move the 5x to the right side, and we'll move the 60 to the right side of the equation. That means we're moving everything away from the left side, so the left side is going to be left at 0. Nothing will be left on the left side. The x squared and the positive 46 will stay the same. But when the 5x comes over, it's going to become negative 5x. And when the 60 comes over, it's going to be negative 60. Okay? We'll combine these two like terms. And we'll also put it in order of variable with the highest exponent to the lowest. So the x squared will start on the left. There's nothing else like the negative 5, so that will be the next term. But we can combine positive 46 and negative 60. We're going to get negative 14 in this case. Okay. And now what we have is we have a quadratic. This is a quadratic that is most likely something we can factor. If we quickly take a look, because it's the a value of 1, we need two numbers that multiply to whatever the c is, which is negative 14. And those same two numbers need to add up to negative 5 in this case. There we go. 2 and 7 work really nicely. 2 and 7, when you multiply them, become 14. But one of them has to be negative. So what we do is we look to the second equation here. And because this is negative 5, if I make the 7 a negative in both scenarios, 2 times negative 7, that gives us negative 14. And 2 plus negative 7, that gives us negative 5. So that's going to be the number that we decompose the middle term by. Okay? And if you're familiar with your factoring here, we don't even have to go through decomposition. Since the a value is 1, we know that we're going to have an x as the first term in both. And one of the values will be positive 2, and the other value is going to be just negative 7. So we've kind of sped up the factoring there because the a value was a 1. It's like a shortcut for it. Finally, because it's two values that are being multiplied to equal 0, it means one of them must be 0. So this is where we split our equation. We're going to set both equations equal to 0 and just solve for the x value. So we're going to end up with two answers, which is exactly what we said at the very beginning of this question. When I move 2 to the other side, x will be equal to negative 2, and x will also be equal to positive 7. Now, we said we'd get a negative answer, and we did, but we said that that's going to be illogical. It wouldn't be 2 weeks in the past that they save up to get the same amount, but it would be this one, which would make the most sense, 7 weeks into the future. Okay, so when we take a look at this, the answer is going to be x is equal to 7, which means in 7 weeks, they will save the same amount. Okay, so there's our like ending statement. And what we can do is just to get a good graphical reading of this. What's that we're looking for? Where? There's my Desmos graph. We're going to just quickly graph the two of them. Y is equal, we said 60 plus 5x was one of the equations. And if you recall, there you go, we'll zoom out a little. There's one of the y-intercepts. The other one, which is Elijah's, I believe, was x squared plus 46.